All right, ready to dive deep. Today, it's something that might sound a little technical at first glance. Casing deformation and induced seismicity.
Yikes. Right.
Yeah, but stick with me, because what if I told you we can now predict these events before they even happen?
And all using something as basic as surface pressure data.
Exactly. We're talking cutting-edge stuff already being used out there in the field, places like the Permian and the Montney Formation.
It's pretty remarkable what's happening out there.
So, in this deep dive, let's break it all down. How this innovative methodology works, its impact on the oil and gas industry.
And of course, the benefits it offers.
Benefits like potentially having a crystal ball for your wellbore.
I like that.
Me too. But first things first, let's set the stage. Why are casing, deformation, and induced seismicity such big problems, especially in unconventional reservoirs?
Well, you're drilling miles underground, immense pressure on that casing, the steel pipelining the wellbore. Now imagine that casing buckling, collapsing.
Costly repairs, right?
Yeah. Oh, way beyond costly. You could have leaks, spills, even lose the entire well. It's a nightmare.
And induced seismicity. That's those small earthquakes we hear about near drilling sites, right?
Often, yes. Human-triggered earthquakes caused by the injection of fluids during fracking.
So basically, potential disasters, damage, delays, environmental risks. How has the industry traditionally dealt with these?
For a long time, we've relied on things like microseismic monitoring, DAS, caliper logs,
DAS being
distributed acoustic sensing. Sorry. But all these tools, they often give information after the fact. Reactive, not proactive. They tell us what went wrong after it's already happened.
So the key question becomes, what if we could get ahead of the curve, prevent these events in the first place?
That's the million-dollar question, and that's where this new technology comes in. By analyzing real-time surface pressure data, we can forecast the likelihood of these events happening.
Okay, hold on. I'm having trouble wrapping my head around that. How can you predict something like an earthquake or casing failure just by looking at surface pressure?
It's all about clever signal processing and machine learning. A three-step process, actually. First, we use something called nonlinear decomposition.
That sounds a bit complicated.
Think of it like this. You're listening to an orchestra, a whole symphony, but you only want to hear the violins.
Okay.
Nonlinear decomposition helps us isolate specific components. The subtle vibrations, those whispers within the pressure data, that might be warning signs.
So filtering out the noise, focusing on the whispers that could tell us something's up.
Exactly. Then, step 2 is feature extraction. This is where the machine learning comes in. We train an algorithm to spot patterns that might be connected to stress on a fault line or changes in rock formations. It's like teaching a detective to find clues.
So the algorithm is a subsurface detective.
Exactly. And then, step 3, predictive modeling. Now, armed with all this knowledge, the algorithm uses those patterns, those extracted features, to forecast what's likely to happen downhole.
So, just like you said earlier, we've got a crystal ball for our well bore. But does this actually work in the real world? It all sounds pretty theoretical.
Far from it. We've seen field tests, and the results are impressive. The Permian, the Montney, even the Vaca Muerta Formation in Argentina. Successful predictions, sometimes hours, even days before anything noticeable happened down a hole.
Wow. That's pretty remarkable to see those warning signs in advance.
It's a game changer for operators. Gives them time to adjust, prevent a much bigger problem later on.
So not just avoiding disaster, but also making drilling and completion smoother, more efficient.
Which is where those benefits we talked about really come into play. And those benefits, they go way beyond just the technical stuff.
Okay, I'm all ears. Break it down for me. What kind of broader impact are we talking about?
Well, think about it. Safety first and foremost. Preventing these events, that means we're protecting workers, equipment, and the environment from potential harm.
Right, and as we touched on earlier, there's that operational efficiency boost as well. Fewer disruptions, unplanned downtime, which translates to smoother operations and potentially big cost savings.
Absolutely. And by reducing induced seismicity, we're also minimizing that impact on nearby communities and ecosystems. A win-win for everybody.
For sure. It sounds like this technology really dovetails nicely with that growing focus on responsible resource development, environmental stewardship.
It's a prime example of good corporate citizenship. Proactively mitigating risk, being a good neighbor to those communities where these operations take place.
It feels like we're witnessing a real shift here, from that reactive mindset to a proactive approach to well management. Would you agree with that?
100%. You hit the nail on the head. It's all about getting ahead of the curve. Using data to make informed decisions Decisions that enhance safety, boost efficiency, and improve environmental performance. Pretty exciting stuff.
It is. It's fascinating how something as seemingly simple as surface pressure data can have such a profound impact, these ripple effects across the entire operation.
Exactly. This allows for better well design, completion strategies, and ultimately increased production and profitability.
It's not just about averting disasters. It's about making the whole process smarter, more efficient.
You got it. And that's where the true value of this technology lies. Not just a reactive tool for damage control. It's a proactive instrument for optimizing every stage of well development.
So this innovative methodology, it really is a game changer. But let's get down to brass tacks here. How is this technology actually being used to improve operations, like on a day-to-day basis?
One of the key applications is in real-time decision-making. During hydraulic fracturing, as that pressure data comes in, the system continuously analyzes it, looking for those telltale patterns that we talked about. If it detects an increased risk of casing deformation or induced seismicity, it can alert the operator immediately.
Giving them time to take action before things get out of hand.
Exactly. They can adjust the pumping rate, change the fluid composition, even temporarily halt operations until that risk subsides. This approach not only prevents costly, dangerous incidents, but allows for smoother, more efficient operations overall.
Like having a guardian angel watching over that wellbore, whispering in your ear when something's not quite right. But seriously, this is pretty incredible stuff.
It's a game changer for sure, and this ability to foresee potential problems, it creates a ripple effect throughout the entire operation.
Leads to better well design, optimized completion strategies, and ultimately, as we mentioned, increased production and profitability.
Right. So it's not just about averting disasters, it's about making the whole process smarter, more efficient from start to finish.
Okay, I'm sold. But I gotta ask, what about the cost of all this? Implementing something this sophisticated, that can't be cheap.
That's a valid point. Upfront costs are always a consideration for operators. But I think it's important to put this in perspective. Look at the bigger picture.
The bigger picture being
The potential savings from preventing even one major incident. A casing failure, a significant seismic event, environmental damage. That could offset the implementation cost many times over.
so not just an expense, it's an investment.
Exactly. An investment in risk mitigation, operational efficiency, and long-term sustainability. And when you factor in those potential benefits, like reduced downtime and increased production, the economic case gets even stronger.
We're talking long-term value creation, not just short-term cost cutting.
You got it.
It's interesting how this technology is forcing us to rethink that traditional cost-benefit analysis, to look beyond just the immediate returns and really consider the long-term value, the long-term impact.
It is a necessary shift in thinking, and not just for energy, but any industry embracing these kinds of advancements.
Right. We've covered a lot of ground here, the technical nitty-gritty, the broader implications, and the impact on how the whole industry operates. But before we wrap up, I wanted to circle back to something you said earlier, the human element. This tech is a tool, not a replacement for human expertise.
It's absolutely critical to emphasize that. This technology is amazing. It gives us these incredible insights, predictions, but it cannot replace the expertise, the judgment of those engineers, geologists, operators out there in the field.
So it's not about automating ourselves out of the equation. It's more like augmenting our ability.
Exactly. Empowering the people on the front lines to make better decisions, more informed decisions based on real-time data.
It's about that synergy between human ingenuity and technological innovation.
That partnership, that's what's going to unlock the full potential of this tech, drive real progress in energy and beyond.
I love that. It's not about replacing humans with machines. It's about creating this powerful partnership. And that brings us to the end of part 2 of our deep dive.
It really is. And, it speaks to this remarkable progress that's happening, when technology and responsible resource development come together.
Thinking about everything we've covered, I'm struck by how this isn't just about preventing those very specific things, those disasters downhole.
Yeah.
It's almost like we're changing the way we think about risk altogether.
How so?
Well, we're moving away from reacting, from just responding when things go wrong, to a more anticipatory approach, wouldn't you say?
You're right. That's a really insightful point. Traditionally, a lot of industries, energy especially, have had that reactive mindset when it comes to risk management.
Identify the hazards, put safeguards in place, cross your fingers, and then scramble when something inevitably goes wrong.
Exactly.
Like they say, closing the barn door after the horse is bolted.
Right. But this new technology, it flips that whole script. Now we can anticipate those problems before they even happen, take steps to prevent them. It's a huge shift in how we think about risk, a shift in the entire mindset. And I think, well, this could change things in a lot of industries, not just energy.
Makes you wonder, what other applications are out there, just waiting to be discovered? If we can use this pressure data to predict earthquakes, wellbore failures, what other risks, these hidden risks, could we be detecting, preventing?
It's really exciting to think about infrastructure, for example. Imagine monitoring bridges, tunnels, pipelines, all in real time using sensor data, predicting structural weaknesses, potential failures long before they'd happen.
Preventing accidents, saving lives.
Exactly. And then you take those same principles, apply them to healthcare, using real-time patient data to predict medical emergencies, to personalize treatment plans, improve outcomes across the board. So many possibilities.
It's like we're stepping into this world where data empowers us to be proactive in all aspects of our lives,
Yeah.
not just reacting after the fact.
That's the power of this tech revolution we're in the midst of. It's not just the tools, it's this fundamental shift in how we approach problems, how we find solutions. Really, it's pretty remarkable.
It is, and it's been an amazing conversation exploring all this with you. We've gone deep into the technical details, the impact on energy, and even how all of this can change the way we think about risk, innovation, the whole nine yards.
It has been a pleasure. Really enjoyed it.
And to all our listeners out there, thank you for joining us on this deep dive. Hopefully you've come away with a new appreciation for the power of data and the possibilities that are out there just waiting to be explored. So until next time, keep those questions coming, keep exploring, and keep diving deep.